Dear students, now we move on to the next chapter, differentiation. I hope all of you have copied down the formulas that is given to you. The whole chapter is covered in the formula wise. Copy down the formulas, by heart the formulas, and now we are going to apply those formulas on questions. So everyone should be aware of the formula, only then the chapter becomes easy. Derivative, what we studied last year, derivative of sin x, cos x, derivative of cos x minus sin x, derivative of tan x, sec squared x, derivative of cosec x into cot x, derivative of sec x into tan x, etc. and so on. Derivative of e raised to x, derivative of log x, 1 by x, derivative of root x, 1 by 2 root x, and so on. I have given you the formula, copy down, study, okay, and we will go on to the next chapter, what is called as differentiation. Now, what do you mean by differentiation, or what do you mean by derivative? Now, suppose there is a function f of x. It goes to an operator, d by dx. This operator is called as the differential operator. It is called as the differential operator. And after the differential operator, it comes out as d by dx of f of x. d by dx of f of x, sometimes it is written as dy by dx. dy by dx doesn't mean you are dividing dy by dx. dy by dx does not mean you are dividing dy by dx. What is dy by dx? Let us take an example. d by dx of the function. What is derivative of cos x is equal to minus sin x. d by dx of tan x is equal to sec squared x. d by dx of root x, 1 by 2 root x. d by dx of x raised to n into x raised to n minus 1. d by dx of a constant, derivative of a constant is equal to 0. So, many formulas what you studied last year, I have given you as a note. Revise those formulas. So, d by dx is just a differential operator. So, under which when it goes to the goes through the differential operator, the function becomes dy by dx. d by dx of cos x is equal to minus sin x, and so on. So, you have to know the formula. And using this formula, there are different methods of differentiation. First one, using the chain rule, implicit function, parametric function, etc., and so on. Logarithmic differentiation, exponential differentiation, and so on. So, we will discuss one after the other how to find the derivatives. Take down the question. Find the derivatives of the following. Find the derivatives of the following. Derivatives of the following. What does it mean? d by dx of tan of 2x plus 3. So, the differential operator d by dx, tan of 2x plus 3. So, you take this as x in your mind. Tan x. What is the derivative of tan x? Sec squared x, 2x plus 3. Then comes 2x plus 3. Derivative of 2 into x. 2 into derivative of x with respect to x, 1, plus derivative of 3 is equal to 0. Derivative of a constant is equal to 0. So, the answer is equal to 2 into sec squared 2x plus 3. It's the answer. So, it is it's very easy provided you know the formula. Second one, d by dx of derivative of sine of cos of x squared. This is also called as derivative using chain rule. Sometimes the name chain rule may be given. Chain rule, you know that chain, one after the other, one after the other. It should go as a chain. So starting from the outer one, you go to the inner one. So derivative of sin x, you first take this as x, sin x is equal to cos x, cos of cos x squared, cos x squared. Then derivative of cos x minus sin x, minus sin x. Then derivative of x squared, it is equal to 2x. Derivative of x with respect to x, it is equal to 1. So what is the final answer? It is equal to minus 2x into sin x squared into cos of x squared. This is also called as the chain rule. Sometimes they may ask you find the derivative using the chain rule. So you should understand from the outer one. Suppose when you enter a house, what will you do? You go to the gate, open, front door, open, next door, next door, next door, and so on it goes on. So in the same way, outer one, next outer, next, and so on should go on. Next one, d by dx of cos of sin x. So the outer one is cos x. Cos x is equal to minus sin of sin x. Then comes the next one, sin x. What's the derivative of sin x is equal to cos x. Now, suppose the function is an implicit function. Suppose the function is an implicit function. How to find the derivative? First question, x minus y is equal to pi. Find dy by dx. Keep as such, find the derivative. Derivative of x with respect to x. X with respect to x 1 minus derivative of y dy by dx. Pi is a constant. Derivative is equal to 0. Or minus dy by dx is equal to minus 1 or dy by dx is equal to 1. Second question, y plus sin y is equal to cos x. Y plus sin y. Derivative of y with respect to x. That is dy by dx plus sin y is cos y. Again y dy by dx is equal to cos x. The derivative is minus sin x. But you can see that in both the terms dy by dx is common. Dy by dx into 1 plus cos y is equal to minus sin x, or dy by dx is equal to minus sin x divided by 1 plus cos y. Clear? Now, dy by dx is called the first order derivative. Dy by dx is called the first order derivative. Dy by dx is also called first order derivative. Sometimes denoted by the notation y1. Sometimes denoted by the notation y1. So, y1 means it is dy by dx. And here, because you have a denominator, you have to restrict the value of y. Y not equal to 2n plus 1 into pi. Because if this happens, denominator becomes 0. So, whenever you have a denominator, you should mention the condition that the denominator does not become 0. Next one, 2x plus 3y is equal to sin x. 2x plus 3y is equal to sin x. Differentiate. 2 into derivative of x with respect to x1 plus 3 into derivative of y with respect to x y1 is equal to cos x, or 3y1 is equal to cos x minus 2, or y1 is equal to cos x minus 2 divided by 3. This is the same as dy by dx equal to cos x minus 2 divided by 3. Cos x minus 2 divided by 3. So, all these questions are quite easy. Only thing is you have to understand or you have to by heart the formulas. This is called as a implicit function. First one we studied about the chain rule. Next comes the implicit function. Copied? Yes. Next one, question number 4. Ax plus by squared is equal to cos y. Ax plus by squared. Implicit, how can you understand it is an implicit function? Because you cannot separate x and y. That is the only technique. A into derivative of x with respect to x is 1 plus b into derivative of y squared 2y into y1 is equal to minus sin y into derivative of y with respect to x is y1. 2b y1 plus sin y into y1 is equal to minus a, because I brought all the y1 terms to one side. y1 into 2by plus sin y is equal to minus a, or y1 is equal to minus a divided by 2by plus sin y, or y1 is the same as dy by dx is equal to minus a divided by 2by plus sin y. For the exam, you can see that the question will come like that. Find the derivatives of the following. And find the derivatives of the following means from each type one questions will be asked. They will not mention which method to do. you may be, the question will be a general question, find the derivative. So you should know which method to adopt. Now this is an implicit function. First one we studied about the chain rule. So you should know how to do the differentiation for each category. Next one. Question number 5. xy plus y squared is equal to tan x plus y. Very important question. xy plus y squared is equal to tan x plus y. xy means x into y. Here you have to apply the product rule. X into derivative of y with respect to x, y1, plus y into derivative of x with respect to x is 1, plus 2y into y1 is equal to tan x is 6 squared x plus y with respect to x is y1. Collect the terms in y1. What are the terms in y1? This contains y1, y1, y1. That is xy1 plus 2y1 plus, this becomes minus y1 is equal to 6 squared x minus y. 6 squared x minus y. Or y1 into x plus 2y minus 1 is equal to 6 squared x minus y, or y1 is equal to 6 squared x minus y divided by x plus 2y minus 1. What is y1? Or dy by dx is equal to 6 squared x minus y divided by x plus 2y minus 1. Question number 6. x squared plus xy plus y squared is equal to 100. X squared derivative 2x. X with respect to x 1 plus x into y, product rule. X into y1 plus y into derivative of x with respect to x 1 plus y squared 2y y1 is equal to derivative of a constant is equal to 0. Now take the terms in y1. xy1 plus 2y y1 is equal to minus 2x minus y, or y1 into x plus 2y is equal to minus of 2x plus y. dy by dx is equal to minus of 2x plus y divided by x plus 2y. Sin squared y plus cos xy is equal to pi. Sin squared y plus cos xy is equal to pi. Starting from the power rule, 2 sin y cos y y1 plus cos of xy will be minus sin xy into product rule. X into y1 plus y is equal to derivative of pi is equal to 0. That is 2 sin y cos y y1 minus x into sin xy y1 minus y into sin xy is equal to 0. 2 sin y cos y is equal to sin 2y. 2 sin y cos y is equal to sin 2y. So from this I can take y1 outside. y1 into this I can write it as sin 2y minus x into sin xy is equal to y into sin xy, or y1 is equal to y into sin xy divided by sin 2y minus x into sin xy. Next one, clear? Okay. Next one, it is the parametric differentiation. Parametric differentiation. So what are the methods of differentiation we studied? Chain rule, implicit function, implicit form. Next one, parametric form. That is, x may be given as a function of theta. That is, x is equal to sin theta. Y may be given as another function of theta. Let us take y is equal to cos theta. In the previous cases, it was like y is equal to cos x plus 2. Find dy by dx. You found minus sin x plus 0 is equal to minus sin x. So directly connected x and y. But in this case, in 1 and 2, it was like x and y directly connected. In this case, x is a function of theta, y is another function of theta, x is a function of theta, y is a function of theta, and the question is, you have to find dy by dx. Dy by dx. So dy by dx is equal to dy by d theta into d theta by dx. Whenever you do a parametric question, always write this formula because it carries half a mark. Parametric form. So first you write y because you need dy by d theta. Y is equal to cos theta x is equal to sin theta. dy by d theta, cos theta is minus sin theta. dx by d theta is equal to cos theta. Therefore, dy by dx is equal to dy by d theta minus sin theta into d theta by dx. You have found dx by d theta 1 by cos theta. That is equal to minus tan theta. This is called as a parametric differentiation. Instead of theta, you may get some other parameter like t, etc., etc., and so on. So you should be very careful about the parameters. Take the next question. Find dy by dx. Find dy by dx if x is equal to a cos theta, y is equal to a sin theta. So, on observation, you know that it belongs to the parametric form. Write the formula. Dy by d theta is equal to dy by dx is equal to dy by d theta into d theta by dx. Divide the page into 2. Y is equal to a sin theta, x is equal to a cos theta. dy by d theta is equal to a into cos theta. dx by d theta is equal to a into cos theta minus sin theta. Therefore, dy by dx is equal to dy by d theta a cos theta into d theta by dx. But here you have dx by d theta. That is 1 by minus a sin theta. A cancel. That is minus cos theta by sin theta is equal to minus cot theta. Minus cot theta. Next one, x is equal to at squared, y is equal to 2at. This is what I told you. Parameter can be t, theta. Must be very careful. So this is a parametric form. dy by dx is equal to dy by dt into dt by dx. Half a mark part. Divide the page into 2. Y is equal to 2at, x is equal to at squared. dy by dt is equal to 2a is a constant. Derivative of t with respect to t, 1, is equal to 2a. dx by dt is equal to a into derivative of t squared, 2t, into derivative of t with respect to t, 1, is equal to 2at. Therefore, dy by dx, dy by dt into dt by dx, 1 by 2at. 2a and 2a cancel. It is equal to 1 by t. Isn't it easy? Yes or no? Yes, it is easy, provided you know the formulas. Next one, prove that x is equal to a into theta plus sin theta y is equal to a into 1 minus cos theta is equal to tan theta by 2. Tan theta by 2. So, prove that dy by dx is equal to tan theta by 2. If x is equal to a into theta plus sin theta, y is equal to a into 1 minus cos theta. Now, here the answer is given to you. So, you have to simplify and you should get the answer till tan theta by 2. By observation, it's clear. It does not belong to the chain rule. It does not belong to the implicit form. It belongs to the category of parametric form. So, half a mark part, dy by d theta, the parameter is theta, is equal to dy by dx is equal to dy by d theta into d theta by dx. Divide the page into 2. Y is equal to a into 1 minus cos theta. X is equal to a into theta plus sin theta. Dy by d theta is equal to a into derivative of 1, 0, minus derivative of cos theta minus sin theta. 0 minus minus is equal to a into sin theta. Dx by d theta is equal to a into theta. Derivative of theta with respect to theta 1 plus derivative of sin theta is cos theta. That is equal to a into 1 plus cos theta. Dy by dx is equal to dy by d theta, a into sin theta into 1 by a into 1 plus cos theta. A and a cancel. Sin theta by 1 plus cos theta. But your answer is tan theta by 2. You have to convert into that form. So, sin theta can be written as sin 2 theta is equal to 2 sin theta cos theta. 1 plus cos theta is equal to 2 cos squared. 1 plus cos 2 theta is equal to 2 cos squared theta. Making use of this formula, this can be written as dy by dx is equal to sin theta. Half the angle sin 2 theta became theta. So, sin theta will become 2 sin theta by 2 cos theta by 2 divided by 1 plus cos 2 theta is 2 cos squared theta. So, 1 plus cos theta will be 2 cos squared theta by 2. 2 cancel, cos theta by 2, cos theta by 2 cancel. So, that is sin theta by 2 by cos theta by 2 is equal to tan theta by 2. So, this is how you do the parametric differentiation. Next one, find dy by dx. Completed? Yes. Find dy by dx if x raised to 2 by 3 plus y raised to 2 by 3 equal to a raised to 2 by 3. X raised to 2 by 3 plus y raised to 2 by 3. I think this is 6th question. 2 by 3 is equal to a raised to 2 by 3. Now, it's a parametric form, so you should know the substitution. I am taking, let x is equal to a cos cubed theta. I am verifying it. Substitution. Y is equal to a sin cubed theta. LHS. X raised to 2 by 3. A into cos cubed theta raised to 2 by 3 plus a into sin cubed theta the whole raised to 2 by 3. A raised to 2 by 3 cos 3 cos cubed theta raised to 2 by 3 plus a raised to 2 by 3 sin cubed theta the whole raised to 2 by 3. That is a raised to 2 by 3 cos squared theta plus a raised to 2 by 3 sin squared theta, or a raised to 2 by 3 into cos squared theta plus sin squared theta is equal to a raised to 2 by 3, and that's your right hand side. Okay, so you have to find dy by dx. Y is equal to a sin cubed theta. X is equal to a cos cubed theta. A cos cubed theta. Dy by dx equal to dy by d theta into d theta by dx. Dy by d theta equal to a into sin cubed theta 3 sin squared theta into cos theta dx by d theta a into 3 cos squared theta into minus sin theta. Therefore, dy by dx is equal to dy by d theta 3a sin squared theta cos theta into 1 by minus 3a cos squared theta into sin theta. 3a cancel, cos theta cancel, sin theta cancel is equal to minus sin theta by cos theta, and that is equal to minus tan theta. Minus tan theta. But here you have y by x is equal to a sin cubed theta by a cos cubed theta. They cancel. That is equal to tan cubed theta. But here you have got tan theta. So what is tan theta is equal to cube root of y by x. So this can be written as dy by dx is equal to minus cube root of, what is tan theta is equal to y by x. Clear? So I think we have discussed three methods: chain rule, implicit form and the parametric form. In the next class we will discuss some other type of differentiation. Before that, you do all the questions based on this 3 types from the exercise, and some other questions will be provided by the other teacher. Submit the assignments. Submit the assignments, and next Saturday you will have a test paper on these 3 sections: chain rule, implicit form, and the parametric form. 3 forms. Okay, thank you.